Hey everyone, it is Mr. Canfield. Today we're going to be in Chapter 8. We've been burning through, doing lots of stuff in Chapter 8. Techniques of differentiation. I'm going to be in the page 35, so fourth or fifth page of it. So now it's just kind of a bunch of applications of the different things we've been looking at. So this first one says, find the equation of a tangent line to the graph of f at the point. And it says to use the calculator to confirm our result. So here's 8a. It says f of x is equal to 3x cubed minus 2x squared minus x plus 2, and it wants at 1, 2. So we'll jump into this. So the equation of a tangent line. Well, remember, a tangent line is just a line, and I like to use point-slope form. So we can look at slope-intercept form as well and how we would handle that. So if I'm doing point-slope form, well, wait, it already tells me what point we want the line at. So, I mean, like, we already know I can plug in the 1 and the 2, so I'm going to be like y minus 2. I don't know m, though, but I do know x minus 1. So, okay. Now, if only I could find m. So I just want to remind you that m stands for slope. And what we've been doing for the past couple of weeks now has been derivatives, and derivatives are slope. So all I got to do is, if I find the derivative here, which, oh boy, this is actually a really easy derivative. 3 times 3 is 9. Subtract 1 from there, so we get x squared. 2 times 2 is 4. Subtract 1. Then that's a plain x, so it's going to be minus 1. That's a number, so it's 0. Boom. But it says we want the derivative at 1, 2. I see 9x squared minus 4x minus 1. It's in terms of x, so I'm going to want to plug an x in. The x value I'm going to plug in is the 1 from the point that we care about. So if I do that, I get 9 times 1 squared minus 4 times 1 minus 1. Then if I do 9 times 1 squared is 1, so it's just 9. Same thing here, 4 times 1 doesn't change, so it's minus 4, then minus 1. Just be careful with your arithmetic here. 9 minus 4 is 5 minus 1. So I got 4. That's our slope. Literally it. I'll do the next one in slope-intercept form. So b, it gives us the function x squared. Oh no, is my fun pen running out of ink? No, it looks okay. So I'm just copying it all down. So x squared minus 4x plus 2 times 4x minus 1. And then it wants at 1, negative 3. So similarly, we have the beginning. We have a good chunk of this already done. I'll take the x minus 1. I'm not going to know my slope yet, but I do know I can take y minus negative 3, which is y plus 3. So all I need to do now is find the slope, and to find the slope, I'll take the derivative. Wait, it's two things times together. I need to remember that I have to do a special rule. So since they're times, I got to take the derivative using product rule, so I'll take the first derivative. I'll leave the second one alone. Plus, I'll take the second derivative, and I'll leave the first one alone. That is how I legit do product rule. There are lots of different ways to do it. That's my preferred method. So this is f prime. And then it says at 1, 3. Well, again, we have x's here, so I'm going to plug in 1 for x. And the easiest place to screw this up is here. In class, when we were doing this, we had, I think, if I'm not exaggerating, I think I heard 4 different answers. There were at least 3 different answers. And this is supposed to be the easy part, but arithmetic is so easy to mess up. So let's see. So if I go in, I'll clean up this group of parentheses first. 2 times 1 is 2 minus 4. I get negative 2 for that. 4 times 1 minus 1, so that's 4 minus 1 is 3. And then here, so 4, and then inside that parentheses, I'm going to get 1 minus 4, negative 3, plus 2, negative 1. So I get negative 6 minus 4, so I get negative 10. And that's our slope. Oh, I said I was going to do this one in in slope-intercept form. Okay. So if we're doing slope-intercept form for this, all right, so we'll do y equals mx plus b. So we know that negative 10 is our slope. So we still know y equals negative 10x plus b. And then I can take this point and substitute it in, because it's supposed to pass through this point as well. So I'll just substitute it in for x and y, because the y is negative 3, the x is 1. And I get negative 3 is equal to negative 10 plus b, add the 10, add the 10. I got b was equal to 7. So then that's y equals negative 10x plus 7. My favorite way to ask these questions is to write an equation of the tangent line. That's kind of a hint that both of those are correct. And a double check if you really feel like it. I mean, if we distribute the negative 10 here, we'll get y plus 3 is equal to negative 10x plus 10. I'll subtract the 3 from both sides, and I'll get y is equal to negative 10x plus 7. So surprise, surprise, that and that are exactly the same. So it's really whatever way you're more comfortable with. This is significantly less work. But you do have to know how both happen, because either of these could be the answer on a multiple choice test. So part C, 8 over x minus 8 over x squared. Here we go. So I didn't get to these examples in class because we were short on time. So first I have to find f prime, at negative 2, negative 6. So I do like to, especially when I'm teaching this, I like to go, oh yeah, we already know it's y plus 6, and we already know it's x plus 2. This is why I like using point slope, because we know the point, boom, hey, we're 3/4 of the way there, we just need that. So back to f of x, I'm going to try to find f prime. Well, before I find f prime, I'm going to rewrite this as 8x to the negative 1 minus 8x to the negative 2. Yes, you could do quotient rule on both of those. No, I don't think that's a good idea. Sounds really nasty. Anyway, so f prime of x then is going to be, 8 times negative 1 is negative 8, and we'll subtract 1 from that exponent and get negative 2, minus 2 times 8 is 16, and they're double negatives, so plus 16, x to the negative 3, and I'm kind of going to go back on everything I've said so far this year. I'm just going to put the negative 2 in now. I'm not going to, who cares about flipping? Negative 8 times negative 2 to the negative 2 plus 16, negative 2 to the negative 3. Well, gee, if you don't know what those are, now flipping maybe makes sense. That's negative 2 squared down here plus 16 over negative 2 cubed. And 2 squared is 4, and the negative goes away on that. So we get negative 8 over 4, and then negative times a negative times a negative is a positive. So this time we wind up getting a negative 8 on the bottom. Oh, my pen is running out of ink. Hold on one second. There. Okay, so there, that one's alive. Ignore the fact that it's slightly changed color. So negative 8 over 4 is negative 2. 16 over 8 is also 2, so it's negative 2 minus 2. I got negative 4 for my slope. Go drop it in, negative 4, and we're done. Cool. So I haven't really used this pen at all. It's fuzzy. This one's also fuzzy. This one's got a better top. This one has more fuzz in general. And now this one actually has ink, so. All right, example D. So D said, why did I write D equals? D says x minus 4 over x squared plus 4, that's our f of x. And we want it at 2 comma negative 1/4. And you might be thinking, that's awful. Well, Yes and no. Because I can say y plus 1/4 is equal to, we don't know the slope yet. We know it's x minus 2. Oh, okay. If I do my derivative and plug in 2, then I'll get the number there. So my derivative is f prime of x is equal to, got to do quotient rule. So derivative at the top is 1. Leave the bottom alone. And then minus, derivative at the bottom is 2x. Leave the top alone. And then on the bottom, we have the bottom squared. That's f prime. I don't care what this simplifies to. I'm going to plug 2 into that. So I'm going to get 4 plus 4 minus 4 times 2 minus 4 over 4 plus 4 squared. That's a lot of 4s. So I was plugging in 2 to all these, and I was squaring the 2 to get 4, and doing 2 times 2 and got 4. I was skipping a couple steps as I was going. So then I'll get, let's see, 4 plus 4, I almost said 16. That's 8 minus 4 times negative 2 all over 8 squared, which is, let's see, 8 plus 8 over 64, which is 16 over 64. And then if I want to simplify that, these are both divisible by, I mean, I could do 2, I could do 8, but they're both divisible by 16. It's 1/4. Final answer, 1/4. You guys doing slope-intercept form, you have fun with that on this problem. I much prefer to just be done there. All right. Cool. On to number 9. So number 9 talks about the equation of the normal line. So I'm going to pretend I didn't read that, and I'm just going to do the last question all over again. But Mr. Campion, I'm not allowed to do that. No. It's like I'm doing the problem secretly, but I'm just pretending that I forgot that I'm supposed to find the normal line. Okay, so if I want to find the tangent line, well, I'm going to do what I normally do. I'm going to say y plus 9 is equal to, and then we'll say x minus 3. And I'm going to write tangent line. Okay, so then I'll find f prime of x is equal to 3x squared minus 8x. And then I'm going to plug in 3, right? So we'll do 3 times 9 minus 24. I got 27 minus 24, which is 3. So the tangent line has a 3 there. Oh wait, I was supposed to do the normal line. Oh man, I gotta do so much more work now. Normal line is exactly the same, except take your slope and find the perpendicular slope to that. Normal line just means find the perpendicular to the tangent. Well, hey, if you want to find a perpendicular line, you take the slope, you flip it upside down, and you make it the opposite. This was already positive, we'll make it negative. Boom, normal line, done. Slope-intercept form works a little differently. We couldn't just take the normal equation from slope-intercept form and change it to the perpendicular slope. We would have to find b all over again. So it's more annoying that way. All right, 9b. 9b says f of x is equal to negative 6 over the square root of x plus 1 at, and it's just the square root of x and a plus 1, okay, at 4 comma negative 2. So again, I'm going to say, well, y plus 2 is equal to, don't know slope yet, x minus 4. So, and then when I take the derivative here, so sorry if these have been way crazy off the whole time. All right, let's just take the derivative. So it's a thing divided by a thing, so I'll do the quotient rule. The derivative of the top is 0. leave the bottom alone, minus, I'm going to leave the top alone, and then multiply by the derivative of the bottom, which we'll get to that in a minute. That's actually kind of annoying. All over the bottom squared. So if I'm trying to do that, square root of x plus 1, we'll just remember that the square root of x plus 1 is the same thing as saying x to the 1/2 plus 1. So when I take the derivative, we'll say 1/2 x to the negative 1/2, and the 1 turns into a 0. So I'm going to say 1/2 x to the negative 1/2, and I'm going to leave it like that. And now I'm going to plug in my x value of 4. So wait, 0 times that. I don't care what you are, you're dead. Then the double negatives cancel out. We're going to have 6 times 1/2 times 4 to the negative 1/2 all over. Square root of 4 is 2, so 2 plus 1 squared. So that's a 3, which that's 9. 9's on the bottom, right? 6 times 1/2 is 3. So 4 to the negative 1/2 is 1 over the square root of 4. So then, oh, that's 1 over 2. So then we get, well, 3 and 9, we can make a 1 over 3. 1 over 2 over 3. That's great. No, remember, this is a half divided by 3, or a half times 1/3, or 1/6. So then I can drop 1/6 in up here, call it a day. Nope, I did it again. Nope, that's my tangent line. So my normal line, that one was an accident. We'll do y plus 2 is equal to negative 6 times x minus 4. Cool. Let's keep going. All of these have homework questions that go along with them that are very similar. So if at any point you want to stop the video and go try the homework problems associated with it, you can find them. All right, what's next? Determine the points at which the graphs of the following functions have horizontal tangents. Woo! So 10a, we want horizontal tangents. F of x is equal to x squared plus 2x minus 24. Here, let me, there. Sorry for that. Just trying to get more comfortable. So horizontal tangent. So just want to remind you, a horizontal tangent is where the tangent line looks like this. In general, these occur at vertices of functions. They can also occur at a point like this where like it's flat for a second and then goes up. So there are other places that they can occur, but those are kind of the general ones. So here, if I find f prime of x is equal to 2x plus 2, and I want to find a horizontal tangent, I'm really looking and saying, hey, when is it perfectly flat like that? When is the slope 0? And guys, this is the slope. So when does 2x plus 2 equal 0? There are many ways to solve this. You can do the traditional, subtract the 2 from both sides, get negative 2 is equal to 2x. Divide both sides by 2, and get x is equal to negative 1. It's not the only way. It's not even the way I'd recommend doing it. Personally, for me, I would take the... All right, so we got negative 1 for x, and that means that if we were to look at this, it's going to be one of these kinds of points. If we were to plug it into the original function, it's going to wind up finding an xy point there. So we know that the x is negative 1. We need to find the y point, though. And if I plugged negative 1 back into here, I would get 0, because that's the slope. We don't want to know what the slope is. We want to know what the y value is. So I'll plug negative 1 in here to regular f of x. So I got 1 minus 2 minus 24. So I got 1 minus 2 is negative 1, minus 24 is negative 25. And if we were to go look at the graph, we would actually see a parabola, and it's going to be the minimum of that parabola. So then if we look at, let's see, 10b, x to the fourth minus 4x squared. So again, all we do is, if we're trying to find what we call horizontal tangents, we find f prime. I'm just making sure that it looks okay. 4x cubed minus 8x. And if I go in and try to solve this by setting it equal to 0, and look for horizontal tangents where the derivative is equal to 0, well, let's see, I could factor a 4 and an x out of these two and get x squared minus 2. And then I can set them equal to 0 independently. 4x is equal to 0. Well, that means that x is equal to 0 because we divide both sides by 4 and it just goes away. Here, x squared minus 2 is equal to 0. And then I'll add the 2 to both sides, and I'll say x squared is equal to 2, and I'll take the square root of both sides and get x is equal to plus or minus the square root of 2. And so now we've found 3 different x values. And I need to go back in and plug them into the original to find the y value. So I'll plug in 0, that's an easy one, we get 0. Plug in root 2. So let's be careful there. Root 2 to the 4th power minus 4 root 2 squared. And wait, this is the same as if I plugged in negative root 2. We'll get there. So root 2 to the 4th, that means root 2, root 2, root 2, root 2. So root 2 times itself 2 times. So like squaring it, we'll get 2. Times itself again, you'll get 4. You also say square root of 16, which is 4. Minus 4 times, that's going to be 2. So then 4 minus 8, we get negative 4. If we were to plug in negative root 2, the negative goes away because of the exponents. So those are the points where I have horizontal tangents. Let's see, 10c. X squared minus 3 over x squared plus 1. This is the first one that I'm like, I don't want to do this. I don't want to figure this one out. And you're like, that's me for every problem. Yeah, okay. So let's say f prime is equal to, I'm going to have to do quotient rule because it's top divided by bottom. So let's see, derivative of the top is 2x. And then leave the bottom alone. Minus derivative of the bottom is 2x. Leave the top alone. All over x squared plus 1 squared. So if I'm setting this equal to 0, the first thing I could do is multiply both sides by the denominator, which cancels it out. Sweet. Now I just gotta figure out what this is. So I'm gonna do something a little weird here. Okay, let me do it a more traditional way that you might be more used to. Okay, so more traditionally, we're setting this equal to 0. You distribute over here, you get 2x cubed plus 2x, then minus 2x cubed plus 6x. 2x cubed minus 2x cubed cancel. I get 8x is equal to 0. I'm just getting x is equal to 0. Really? Okay. So the other way that I wanted to try handling this was pulling a 2x out of everything and saying x squared plus 1 minus x squared plus 3. So I just pulled the 2x out of everything and then distributed that negative to those. When I do that, I get 2x times 4, 8x. Doesn't really save us much work for this one, so never mind. Look at me all trying to be fancy. It just doesn't. Whatever. Okay, so I get x is 0. So we got a horizontal tangent when x is equal to 0. Since this isn't a polynomial, this is a rational function, this might have domain restrictions, but that bottom is never equal to 0. So I won't have any domain restrictions. So x is equal to 0, and I can go back to f of x and plug it in, and I get negative 3. So I get 0, negative 3. 10C was actually pretty nice. 10D. 10D says f of x is equal to x minus 1 over x squared plus 3. So let's try to find horizontal tangents for this one. So f prime, we'll take the derivative of the top, leave the bottom alone. Subtract, take the derivative of the bottom, and leave the top alone. All over x squared plus 3 squared. And if you learned anything last time, it's that this denominator does nothing to making this equal to 0. So, because we're going to multiply both sides by it, and it's going to go away. So that means that on my next step, I can just kind of pay attention to the top here and get x squared plus 3 minus, let's see, 2x squared plus 2x. So I distribute that as a negative 2x to those when I was thinking about it. So then here and here, we can get a negative x squared, and then plus 2x plus 3 is equal to 0. So I'm going to solve this 2 ways. The first way I'm going to solve this, I'll do it 3 ways. I'll do the worst way that I know first, and that is to leave this as a negative x and trying to factor it like that. So, and then I know I need a 3 and I need a 1. And I know that they're both plus because it's the only way to multiply to a positive 3. So I need to add to a positive 2 with the x's. So I'm going to need to have that order because that gives me, oh, nope, I'm wrong. If I FOIL this out, I wind up getting negative 2x. So that's going to be plus 3, x plus 1. Let me try that. Negative x squared minus 1x plus 3x. Yeah, there we go. So this is my least favorite way to solve this, but then I'll get x is equal to 3 for that one, and x is equal to negative 1 for that one. And we'll go find our y values in a minute. So that's my, like, don't do that. Please, oh, save yourself the pain. Unless that's easy for you. If that's easy for you, then, like, never mind. The next level up in pain would be quadratic formula. And if we use our memory device, that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, then there, now we got that. And I just got to do the arithmetic on this. Negative 2 plus or minus the square root of, that's going to be positive 12, so that's 4 plus 12 all over negative 2, which is negative 2 plus or minus the square root of 16 over negative 2, or, off the screen, negative 2 plus or minus 4 over negative 2. And so that splits into 2 numbers, negative 2 plus 4 over negative 2, and negative 2 minus 4 over negative 2. That's 4 over, so that's going to be 2 over negative 2, which is negative 1. And that is negative 6 over negative 2, which is 3. Wow, same answers. Okay, now I'm going to do it the way that I would do it. I see the negative x squared, I go, oh, I don't like dealing with that, so I multiply both sides by negative 1, and I get negative, or that turns to a positive x squared, that changes to 2x, that changes to minus 3. It has the same solutions. So now this is a nice easy factoring. We got an x and a 3 and a 1. The 3 needs to be negative, the 1 needs to be positive. Solving both of those, we get x is equal to 3 and x is equal to negative 1. Pick your poison. That's the easiest way for me. One of the other two might be easier for you. So there is not a correct way to do it. There is the way that's going to work for you to do it. Either way, we found our x values. Now we're going to go find our y values. So we'll plug them back into the original. So I'll get 3 minus 1 is 2 over 9 plus 3. So 2/12, so 1/6. Ew. Then I'll plug in negative 1, and I'll get, that's negative 2 on top, and then 4 on the bottom, so negative 1/2. Nice, calm, relaxed numbers. No, okay. So we got a little bit more to go through. Something else I should mention, like the whole purpose of me making these videos is to make class easier for you, or make stuff work for you. So please, if I'm ever going through stuff in a video, and even with like being able to stop it and go back and look at things, like if stuff still isn't working for you, please don't let that be the end of it. Please have a conversation with me. Please let me know how I could make my videos more helpful, including just like, you know, hey, when you were saying this thing, I don't know what you were talking about. Like, can you tell me about it? And then maybe next time I do the video, I'll be able to explain some of that instead of just assume that you're fine. So, all right, so I'm going to do 11a. And 11a says we want to find f prime of 3. These all are asking for f prime of 3. So it says f of x is equal to 4g of x minus 1/2 h of x plus 1. So the derivative here is actually very easy. And I'm not patronizing people, or like I'm not talking down to you if it's hard. It's not hard. F prime is literally equal to, well, it says 4g of x. Well, what's the derivative of g? The derivative of g is g prime. So it's 4 times g prime. The derivative of h is h prime. So minus 1/2 h prime. The derivative of 1 is 0. That's what f prime is. And then all I got to do, well, it says find f prime of 3. That means plug in 3. So 4 times g prime of 3. Well, hey, wait, g prime of 3, if I go look at my table, g prime of 3 is -2. And h prime of 3 is pi. So 4 times -2 is -8. And that's -1/2 pi. And we're done. That's literally it. So 11b says g of x times h of x. Oh. Plus x. Well, if we're going to take this derivative, I want to remind you that we're doing two things times together. That means I got to use product rule. That's where I take the derivative of the first one, leave the second one alone, plus I take the derivative of the second one, leave the first one alone. It's the way I like to do it. There are other ways to write it. There are other ways to format it, but, oh, wait, then plus the derivative of that one because it's on the end. Derivative of the x is just 1, so we'll have a plus 1 at the end. So g prime, now, so if we're doing f prime of 3, all we have to do is go, okay, well, g prime of x, g prime of 3, I mean, it's -2. And h of 3 is 3. Then h prime of 3 is pi. And g of 3 is 4. Then plus 1. So I could write this as -6 plus 4 pi plus 1. And clean it up and get -5 plus 4 pi. Or 4 pi minus 5. Yep. Then we have C. I'm looking for some paper. Wonderful paper. Wait, here we go. Here's some paper. So 11C. 11C says f of x is equal to g of x over 2h of x. And so we just need to be careful. We're going to do quotient rule because it's a thing divided by a thing. So derivative of the top is g prime. Leave the bottom alone, 2h of x. Minus derivative of the bottom, which is 2h prime. Leave the top alone. All over the bottom squared. And hey, we just go to our table. we're doing it when x is equal to 3. So g prime of 3 is negative 2. 2h of x. So that's 2 times 3. Minus 2. H prime of 3 is pi. G of 3 is 4. All over 2 times h of 3, so 2 times 3 squared. Follow the order of operations and we win. I mean, you could just leave it there and you'd be right, but I'm just gonna keep going. So 6 minus 8 pi all over 6 squared. So I got negative 12 minus 8 pi over 36. Could leave it there. Could divide them all by 4 and get negative 3 minus 2 pi over 9. And that's a little bit more simplified. All right. And then on to 11D. G of x minus h of x over g of x. All right, that's our f of x. So we got to do quotient rule again. This time the derivative of the top is a little bit messier. The derivative of the top is going to be g prime minus h prime times the bottom minus derivative of the bottom, which is g prime, times the top that we're leaving alone, g of x minus h of x, all over, g of x squared. And as long as we're careful and put the pieces where they belong, it really should be pretty straightforward. So let's see, g prime is negative 2, h prime is pi, g of x is 4, minus g prime is negative 2, g of x is 4, minus h of x is 3, all over g of x, which is 4 squared. So hopefully I didn't make any silly mistakes. It is so easy to make silly mistakes on these. So I would leave it there on a test because I know I'm so prone to making silly mistakes from here on out. So I get negative 8 minus 4 pi plus, that's a plus 2. So then that's a 1, so it's just plus 2 all over 16. So I got negative 6 plus 4 pi over 16. I could divide them all by 2 and get negative 3 plus 2 pi over 8. But the big deal with this was, well, the derivative of the top here was just, that derivative is g prime, that derivative is h prime. Leave the bottom alone. Like it really is just, it really is just, can we apply the product rule, the quotient rule, these different things, even though it looks funny. Right. The second derivative of a function is the derivative again. Oh man, I've made myself laugh with really stupid things today. It's embarrassing. So f prime for this one would be, well, 3 times 8/3 is just 8 minus 10x minus 7, right? That's f prime. Here's the magic. F double prime. Pretend that the first one wasn't there. What's the derivative of this thing we have here? 16x minus 10. That's literally it. Hey, guess what? You can take the third derivative. F triple prime, yes, that's how you write it, is equal to 16. F quadruple prime, sometimes they'll write it like this. What's the derivative of that? 0. Oh, okay. F quintuple prime, the next one. Derivative of 0, still 0. I mean, so you can be like, oh, I'm going to take 45 derivatives. It's still 0. So you also can write it as, like, if I wanted to take the second derivative, I could say, instead of dy dx, we can say d2y over d x squared. And that notation, we come to understand that notation better in Calc 2. So first derivative, second derivative, if you want to do the 12th derivative, that notation is just saying take 12 derivatives, that's all. So these derivatives are nothing new. You do the derivative, so something like this in letter D, you're going to do quotient rule to get your derivative, and then you have to do like another quotient rule after that, and it's just bleh. So I'll do D. X over x minus 1. Yeah, let me write D correctly. X over x minus 1. Okay, so if we're finding f double prime, so that means that f prime, well, derivative of the top is 1, leave the bottom alone, minus derivative of the bottom is 1, leave the top alone, all over bottom squared. So the problem is taking the derivative of the bottom right now, we don't have a tool to do that right now, to do squared. So, I mean, I guess you could do product rule on it. I'm going to clean this up and get a nice answer first. So I'm going to get x minus 1 minus x all over. Then that's going to be x squared minus 2x plus 1. Wait, those cancel. I wind up getting negative 1 over x squared minus 2x plus 1. So that's f prime. So then f double prime is going to be, derivative of the top is 0, leave the bottom alone. Minus, derivative of the bottom is going to be 2x minus 2, leave the top alone, all over bottom squared. Right, so that's gone. Those negatives cancel each other out. So I got, for my f double prime, I got 2x minus 2 over x squared minus 2x plus 1 squared. Now, that's good for f double prime. If we wanted to find f triple prime here, we'd have to FOIL out the bottom, and whew, no thank you. Cool. So I hope this was helpful. As always, feel free to reach out. And yeah, hope you all have a good day. Bye.